Okay, let's see nitrogen oxides. That nitrogen oxides N2o. Nitrogen has +1 oxidation state N2o, +2 oxidation state N2o3. Nitrogen has +3 oxidation state NO2. Nitrogen has +4 oxidation state. It diagonalizes to existing N2O4 has +4 oxidation state. N2O5 has +5 oxidation state is present. Among that, N2O and NO are neutral. These are the neutral oxides. The remaining all are acidic. Among these all, which is more acidic? N2O5 has more acidic character. N2O5 has a more acidic character. Let's see preparation methods of nitrogen oxide. The first one is N2O. This N2O we can prepare from ammonium nitrate. NH4NO3 is on decompose to produce N2O plus 2H2O. The second one is NO, nitric oxide. This N2O, nitrous oxide, is also known as laughing gas. Is also known as a laughing gas. NO we can prepare when sodium nitrate NaNO2 reacts with ferrous sulfate in acidic medium, then I use H2SO4. Here 2 moles, and this ferrous sulfate is also 2 moles, then 3 moles of sulfuric acid converts to gives 2NO plus this ferrous sulfate is converted to ferric sulfate. Fe2SO4 thrice. Fe2SO4 thrice plus the remaining sodium atoms and the hydrogen atoms and sulfate. 2 sulfate ions combined to give NaHSO4, sodium bisulfate plus 2 moles of water. Okay, so in this reaction we are getting nitric oxide NO. Nitric oxide is formed. The next one is dinitrogen trioxide. Dinitrogen trioxide we can prepare when it reacts with NO2. NO and NO2. Nitrogen dioxide and nitric oxide upon cooling at 250 kelvins temperature or very low temperature, then we are getting N2O3, dinitrogen trioxide. This dinitrogen trioxide is the anhydride. The anhydride of HNO2, nitrous acid, because HNO2, nitrous acid on heating, then loss of water molecule forms N2O3, dinitrogen trioxide. The next one is preparation methods of NO2, nitrogen dioxide. This nitrogen dioxide can be prepared when lead nitrate PbNO3 twice. This lead nitrate, 2 moles of lead nitrate upon heating, then form 2 moles of lead oxide plus here 2 nitrogen atoms into 4 NO2. 4 NO2. Then here 4 to the 8 plus 2 10, but here 12 oxygen atoms are present. The another 2 oxygen atoms convert into O2 gas. So this is the method for the preparation of NO2. Once you observe that NO2 structure, the NO2 molecule is odd number of electrons containing molecule. Odd electrons. That's why it is typical odd molecule. Typical odd molecule, unstable, and then dimerize to form N2O4. Dimerize it to forms N2O4. Let's see, the next one is N2O4. N2O4, how we can prepare NO2? The NO2 is odd electrons or odd number of electrons containing molecule. That's why it is unstable, and due to the presence of odd number of electrons, it has brown color. It has a brown color and paramagnetic, unstable. Upon cooling, then what happens now? Is converted into N2O4. Upon cooling, it dimerizes. Then the produce N2O4. N2O4 has colorless. Is a colorless, and even number of electrons are present. Even number of electrons are present. N2O4 has even number of electrons, colorless and stable. Stable and diamagnetic. Means there is no unpaired electron, that's why it is diamagnetic. So this is about N2O. This is about N2O. The next one, this once you have observed that NO2 or N2O4 are the mixed anhydrides. These are the mixed anhydrides. Mixed anhydrides of HNO2 and HNO3. Mixed anhydrides of HNO2 or HNO3. Let's see. This HNO2 plus HNO3 on dehydration, loss of water molecule to produce N2O4 or 2 moles of NO2. That's why nitrogen dioxide or dinitrogen tetroxides are the mixed anhydrides of HNO2 and HNO3. The next one, preparation method of N2O5. This N2O5 we can prepare when phosphorus pentoxide, P2O5. This phosphorus pentoxide treated with HNO3. Then forms N2O5, dinitrogen pentoxide plus 2 moles of HPO3, metaphosphoric acid. HPO3 is named, what is the name of HPO3 ma? Phosphoric acid. Its name is metaphosphoric acid. Is 3 HPO3. See here, phosphorus pentoxide generally exists in diameric form. Means P4O10. This, if you are taking P4O10, then it reacts with 4 moles of HNO3, forms 2 moles of N2O5 plus 4 moles of HPO3. This N2O5, nitrogen pentoxide. N2O5 is the anhydride of, it is anhydride of HNO3. It is the anhydride of HNO3. When HNO3 molecules, nitric acid on heating, upon heating, then we are getting N2O5, loss of water molecule. Okay, this is about the preparation methods and some properties of nitrogen oxides. Let's see the structure of nitrogen oxides. Structure of nitrogen oxides. Structures. The first one, N2o. In between nitrogen and nitrogen, double bond is present. In the middle nitrogen, have one more double bond with oxygen. See, this nitrogen has only two bonds. The remaining two lone pair electrons are present. And the middle has a valency or covalency is 4. So these are the Lewis dot structures. If these lone pair electrons are migrating towards this oxygen side, then in between nitrogen triple bond and oxygen and nitrogen having single bond is present. Okay, this is the linear shape, linear geometry. Next, the second one is NO. NO means in between the nitrogen and oxygen double bond is present, and this nitrogen has one single electron is present, odd electron, and this oxygen has two lone pairs are present. The single electron jumps towards oxygen also. That's why the resultant structure is being like this. One bond is 3 electrons, 2 center bond, and it has one lone pair, and this oxygen also has one lone pair. It is also odd number of electrons containing molecule. Odd number of electrons containing molecule. The next important structure is N2o3, dinitrogen trioxide. In between the nitrogen and nitrogen, single bond is present, and one nitrogen valency, covalency is 4, another nitrogen valency is 3. This is a planar molecule. Here 3 lone pairs are present, and this has 2 lone pairs, and this nitrogen has 1 lone pair, this oxygen. This involved in resonance, the resultant structure is being like now. If you have observed that here this nitrogen and oxygen, they have resonance structures. So this nitrogen oxygen bond length is different, this nitrogen oxygen is bond length is different, and nitrogen, 3 types of bond lengths are present. 3 types of bond lengths are present. In the last 2 years back, they asked one important question: among the following nitrogen oxides, which nitrogen oxide has nitrogen bond is present, or which doesn't have nitrogen bond? Which nitrogen oxide doesn't contain nitrogen bond? That is N2O5. N2O5 does not contain nitrogen bond. They contains nitrogen, oxygen, and nitrogen bond is present. In middle, in between the nitrogen atoms, 2 nitrogen atoms are connected by the oxygen atoms in N2O5. Okay. Next one is NO2. NO2 is angular molecule or angular shape. Here nitrogen has one odd number of electrons present, and they have a later one. This is the structure one, and they contains both nitrogen and oxygen bond lengths are identical. Here all nitrogen and oxygen bond lengths are not identical. This right side is different and left side are different. This is the angular shape. Angular shape. NO2 is angular shape. Next, N2O5 because it is a dimer of NO2. That's why in between nitrogen single bond is present and double bond over oxygen, double bond over oxygen. They 2 bond. That's why 3 bond pairs are present and here 2 bond pairs. See here all nitrogen and oxygen bond lengths are identical. Here also identical, but in N2o3 all nitrogen and oxygen bond lengths are not identical. 2 are same, another is different. That point is important one. Now it has resonance structures. In N2O4, nitrogen covalency is maximum covalency is 4. 1, 2, 3, 4 bonds are present. As well as in N2O5 also nitrogen covalency is 4 only. But in N2O3, one nitrogen atom covalency is 4, another nitrogen atom covalency is 3. Covalency is 3. Covalency means bonding capacity. Okay. Next, another one is N2O5. Let's see N2O5 structure. N2O5 dinitrogen pentoxide. This is also planar molecule. So, opposite. These are the Lewis dot structures now. So this is the structure of N2O5. So this is about nitrogen oxides, preparation methods and properties and structures. Okay, next class we will discuss about nitrogen oxyacids. So nitrogen oxyacids, among that main important nitrogen oxyacid is nitric acid. HNO3 preparation methods and properties we will discuss.